Alright, in this video we're going to be talking about how to factor trinomials. So remember that's 3 terms. But this is a specific type of trinomial because these trinomials won't have a coefficient or the coefficient will be 1. You can think about that both ways. So you can think about that as like your A and that your A equals 1. There is a specific rule when we are factoring trinomials when A equals 1. You have to find 2 numbers that multiply BC. Those 2 numbers also have to add to be whatever B is. Once you know those 2 numbers, you basically have to just put it in factored form and it's factored. So let's see what I mean. For number 1, we need to find 2 numbers that multiply to be 12, but add to be positive 7. So until you get the hang of this, I would recommend just listing out your factors. So for 12, we have, I'm going to list them all out and then go through them all. 1 and 12. 2 and 6, and 3 and 4. Those are all the factors that multiply together to be 12. Of those, we need to choose which of these are going to add to be 7. Well, 1 plus 12, or any way I add or subtract them, will not give me 7. So those are out. 2 plus 6, or 2 minus 6, or 6 minus 2, those will not give me 7. But 3 and 4 will definitely give me 7 if I add them. So those are going to be the 2 numbers I use. Once you find those 2 numbers, your factors are going to look like this. You're going to have your 2 sets of parentheses. Whatever variable you have in your polynomial is going to be the variable in both at the beginning. So here I had x. So I'm going to put an x in both. Then I'm going to take the 2 factors I just found, which was positive 3 and positive 4, and I'm going to put that in. That's it. Now, how do we know this works? We're going to distribute this back out, and if we get the same polynomial, then it worked. Think about this as, remember when we were multiplying binomials together to get a polynomial? This is just the opposite of that. X times x, remember our exponent rules. So that would give me x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. I have like terms, I can combine 4x and 3x. So x squared plus 7x plus 12. That was my original, so this works. I would definitely recommend double checking your work, distributing it back out to make sure it works. But the answer you need is the x plus 3 and the x plus 4 in parentheses. Let's keep going. For number 2, we need to find 2 numbers that multiply to be 20 and add to be positive 9. And as you get more and more comfortable with this, you may start thinking about those numbers and have them immediately, and that's fine. But until you get comfortable with that, write out a factor tree. So for 20, I have 1 and 20, 2 and 10, 4 and 5. You may already be looking at that like, oh, I know the 2. I'm still going to go through them. It's okay. 1 and 20, if I add them or subtract them, that will not give me 9. 2 and 10, if I add them or subtract them, that will not give me 9. But 4 and 5 will, if I add them. So my 2 factors are going to be, n is going to be in both of them because I have n's in my polynomial, plus 4 plus 5. I'm not going to distribute it back out for this one, but I will for some of the later examples. Let's jump down to number 7. Now I need two factors that multiply to be negative 18 and add to be positive 3. With your negatives, it's a little bit different because you can think of your factors like we just did, but one of the numbers is going to have to be negative because we ended up with a negative. The only way we can end up with a negative is if one of them is negative. If both of them are negative, it would be positive. So let's think about, I'm just going to write out the factors of 18 first, and then we'll look at the negative aspect of it. So 1 and 18, 2 and 9, 3 and 6. Now let's think about this. If I have negative 1 and positive 18, well that's positive 17, so that wouldn't work. If I have positive 1 and negative 18, that's negative 17, so those are out. If I have negative 2 and positive 9, well that's positive 7, so that's out. If I have positive 2 and negative 9, that's negative 7, so that's out. So it has to be these last two numbers, but we have to figure out which one is negative. If I have negative 6 and positive 3, that would give me negative 3. So that means I need my 3 to be negative and my 6 to be positive, so that way when I add them together or subtract, I get positive 3. So my factors here, I'd have n in both, and then because my 3 is negative, that is now going to be a minus 3 and a plus 6. Just to show you that this one worked, and I would definitely recommend doing this anytime you end up with a negative factor. N times n is n squared. N times 6 is 6n. Negative 3 times n is negative 3n. Negative 3 times 6 is negative 18. I have like terms, n squared plus 3n, because it's still positive, minus 18, which is what I got originally. So this factored form is correct. Let's try another one of those examples. Now we need to find the factors that multiply to be negative 8 and add to be positive 2. Factors of 8, we have 1 and 8, 2 and 4. If I have negative 1 and positive 8, that's positive 7, that would work. Positive 1 and negative 8, that's negative 7, that would work. Negative 2 and positive 4, that would work, because negative 2 plus 4 is positive 2. So my variable is x, and I have minus 2 and plus 4. I did mean to say this earlier, so I'm going to say it now. The order in which you write this does not matter. I could have written plus 4 and minus 2. The order here does not matter which one you write first, as long as you write both and have the correct signs. Remember, multiplication is commutative, so you can switch them if you want. Just to check this, x times x is x squared. X times negative 2 is negative 2x. 4 times x is positive 4x. 4 times negative 2 is negative 8. Combining my like terms, I have x squared plus 2x minus 8. So that works. We're going to go over a couple more of these. Number 16, I have to find two numbers that multiply to be negative 3 and add to be negative 2. Well, 3 is a prime number, so its only factors But because this is negative, only one of them can be negative. If I do -1 and +3, that would give me a +2, so it needs to be -1, +1 and -3. So a plus 1 and a minus 3. If I multiply that back out, I get a squared minus 3a plus 1a minus 3, or a squared minus 2a minus 3. The last one we're going to try is number 18. I need two numbers that multiply to be -72, but add to be -14. 72 has a lot of factors, so any number that has a lot of factors, if you don't know them all off the top of your head, I would definitely advise making your factor tree, just to make your life a little easier to see them all written out. So we have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. I honestly forgot some of them. I had to start dividing. And if you aren't sure how to find your factor tree, just start dividing. 72 divided by 1, 72 divided by 2, and keep going until the numbers are really close to one another. Right? Looking at my factors to get -14. Well, I'm going to eliminate some because there's no way I could add or subtract 1 and 72, 2 and 36, or 3 and 24 to get 14. The numbers are too big. Now 4 and 18, if I have -18 and +4, that would work. So I'd be left with x plus 4 and x minus 18. Just to double check, that'd be x squared minus 18x plus 4x minus 72. Combining my like terms, I'd get that -14x. I forgot, there was one other example I wanted to show you just because it's a little different, and that was number 6. So two numbers that multiply to be 1 but add to be 2. This one's going to be easy because there's only one number that multiplies to be 1, and that's 1. 1 is also prime because it's 1 in itself, even though itself is already 1. But the two numbers we're going to use are 1 and 1. So y plus 1 and y plus 1. Anytime you have double, like this, double the same polynomial, you could change the way you write this. Remember that with exponents, if you have some base and it's being multiplied x number of times, is being raised to a power. So I could say this is the same thing as y plus 1 squared. That would be the same thing. This is what you call a perfect square trinomial. And we'll get into that a bit more later. You will now have time to practice factoring when a equals